For the last 3 sections, we're going to talk about functions and relations. A function is any two sets where every value in one set matches every value, or rather it's assigned to exactly one value in the other set. So the keywords you need to know are domain and range. Domain is your independent variables. That's your input. So here, this is your domain. The range is the set of dependent variables or output values. So that's this. The key here to note is that for any given domain value, the domain only goes to one range. As you see here, we can have two numbers go to the same range, but we cannot have one number go to two different ranges. That wouldn't make it a function. Now for this first example, we're asked for the range and the graph of this particular function that's shown. And we read this, f of x is negative 1/2 x plus 2. And the domain is these values. What that means is we are only allowed to put these values in to x. So as you see in this table, those are the only values we're allowed to have. So if I put 0 in place of x, I get negative 1/2 times 0 plus 2. So my range is 2, and my coordinate is 0, 2. For the next one, if I input 1, that's negative 1/2 times 1 plus 2. Well, negative 1/2 times 1 is negative 1/2, and if I add 2 to that number, I will get 1.5. So I'll just put 1.5. So my coordinates are 1, 1.5. Continuing, 2, so negative 1/2 times 2, that's negative 1, plus 2 is a positive 1. So my coordinate, 2, 1. If I put in 3, negative 1/2 times 3, that's negative 3/2 or negative 1.5. Negative 1.5 plus 2 is 0.5. So the coordinates are 3.5. And then finally, negative 1/2 times 4, that makes negative 2. Negative 2 plus 2 is 0. So my coordinates are 4, 0. So when I graph this, I'm going to graph this set of points. 0, 2, 1, 1.5, 2, 1, 3.5, 4, 0. Please pay attention. I am not connecting these. You guys tend to want to do that. The domain is only these values. It is not any values in between. When you connect coordinate points with a line, what you're saying is that all the points in between are also true. In this case, only these 5 points are allowed, so the graph is just a series of points. When we're given function notation, here we've got f of x is 5x minus 1, and we've got g of x is 2 plus x squared. Real numbers are their domain. What that means is I can put any real number into either one of these functions and get an answer. So for the first one, f of 10, what that tells me to do is put 10 in place of x. G of 7 means go to the g function and put 7 in place of that. For the next two, g of f of 3, f of g of 3, we'll use order of operations. So that means you'll start with the inside function and then move to the outside function. So let's take a look at the first one. G of f of 3 means we're going to take g of 5 times 3 minus 1. Well, 5 times 3 minus 1 is 14. So I will take g of 14. So that's 2 plus 14 squared. 14 squared is 196, so that becomes 198. We can do the same thing with f of g of 3. So that means we'll take f of g of 3 is here. So we'll say 2 plus 3 squared. So that means I'll take f of 9 plus 2, which is 11. And that's 54. So notice, f of g of 3 and g of f of 3 give two very different answers. On this problem, we are given an absolute value function, and we're given 3 different types of domains. So we'll start with the simplest. With this very specific domain that only has 5 values, what is the range? Meaning, when I put each one of these numbers in place of x, what will my output be? So on this first one, the range -2 minus 3, and we're looking at an absolute value, is equal to 5. -1 minus 3 would be 4. 0 minus 3 would be 3. 1 minus 3 would be 2. 2 minus 3 would be 1. So my range is the very specific set of numbers 1, 2, 3, 4, 5. And please note that I didn't list them in the same order as the domain. I listed them from smallest to largest. Now on the next problem, if my domain is all values greater than 3, what will my range be? Well, for this, what I did was I actually plugged in f of 3. I guess I could put 3 minus 3. And I get 0. So anything bigger than 3 will start giving me positive values. So for that one, my range is going to be all values greater than 0. Because exactly 3 gives me 0. So if this is larger than 3, this will end up being a value greater than 0. The final one is all real numbers. And this is something that we need to pay attention to when we are looking specifically at absolute value functions. Now we know if we put in negative numbers like these, we get positive values like these. We know if we put in 3, we get a 0. Because this is absolute value, we'll never get a number less than 0. So in this case, this doesn't really require mathematical work to show, but to understand that if I input all real numbers, my range in this case will be all real positive numbers. So just like the last one, it's all function values. This time it can be greater than or equal to 0. And truthfully, this one should also be greater than or equal to 0.